Hello everyone, welcome to Math Cognizant. In this video, you're going to learn how to find the greatest common factor between the numbers. We have different methods to find greatest common factor. That's a prime factorization. It can be the factor method or it can be the ladder method. In this video, you're going to learn by prime factorization as well as by the factor method. Before, you should know what do you mean by prime numbers. So prime numbers are those numbers which can be divisible by itself or by number 1. So few examples of prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and there are more. Okay, let's see how to find the GCF of 36 and 48 by prime factorization method. 36, we need to write the factors of 36. Factors of 36 can be 2 times 18, it can be 3 times 12, it can be 4 times 9, or it can be 6 times 6. 6 times 6 gives you 36. So now you can pick any one of these, you will get the same answer. Let me pick 4 times 9. 4 is not a prime number, it can be divisible more. It can be factorized as 2 times 2, and 9 can be factored as 3 times 3. The same way, let's write one more tree for 48. 48 also can be written in different ways. 2 times 24, 3 times 16, 4 times 12. So let me pick one of these, that is 4 times 12. We are again factorizing 4, that's 2 times 2. 12 can be written as 3 times, 2 times 6. 2 is a prime number. 6 can be written as 3 times 2 again, or 2 times 3. To find the GCF, in the next step, you need to find what all the common numbers present in both the trees. So 2 is common among both the trees. Let's write these 2 as 1s. And what's the next common number? Again, we have 2 as common. So pick those 2 from both the trees and write it as 1s. Next, we have 3 as common. So times 3. Now there is no more common numbers from both the trees, so let's use these. So we have to multiply all these 3. 2 times 2 is 4, 4 times 3 is 12. So 12 is the GCF of 36 and 48. This is one of the method. Let's see the other method, that's a factor method. To do the factor method, let's start writing the factors of 15. 1 times 15 gives us 15. We don't have 15 in times table of 2. So we need to write it as 3 times 5 equals to 15. And 4 times we don't have it. Next is a 5. 5 times 3 is equals to 15. Now when you start getting the repeated factors, we need to stop there. Okay, and write down all these factors. That's 1, 3, 5 and 15 are the factors of 15. 1, 3, 5 and 15. In the same way, we need to find the factor of 40. 41 times 40 gives us 40. 2 times 20 gives us 40. We don't have 40 as a product in times table of 3. We have it in times table of 4. That's 4 times 10 is equals to 40. 5 times 8 equals to 40. We don't have 40 as a product in times table of 6 and 7. Yes, we do have it in times table of 8. 8 times 5 equals to 40. But we get the repeated factors here. 5 times 8 and 8 times 5, so we don't consider the other one. So what are the factors of 40? 1, 2, 4, 5, 8, 10, 20, and 40. From these factors of 15 and 40, what are the common numbers? We have 1 as a common and 5 as a common, and rest of the numbers, neither of the numbers are being common. So from these two, 1 and 5, that's a common, which is the greatest one. Since we are finding the greatest common factor, 5 is the greatest. So greatest common factor, that's GCF of 15 and 40 is equals to 5. So these are the simple ways by which you can find the greatest common factor. Hope you understood this lesson.